Good evening and welcome to Rubber Duck Engineering. Now that we have successfully escaped the forest of tracing, we are now going to enter the prairie of tag pointers. I don't know. Good evening, Dr. Mark.
I was going to say the woods. Like, now that we escaped the forest, we're in the woods.
Yeah, I worry that just like that engineering estimate was off by an order of magnitude, this one may be as well. But we're going to attack tag pointers tonight. It's going to be amazing.
A wise person told me you should take every engineering estimate, multiply it by 3, and add 1. Which I think is especially
well within bounds then.
Because it's like not a linear function. Like, depending on the units you use to express the deadline, you get a different correction.
I guess that's true. So yeah. Also, we hopefully we'll have a special guest next week. I think so. We have them booked. Hopefully they will come.
Oh, that'll be fun.
It will be fun. Shall we do the code machine?
Yes. Let's do the code machine.
Yes, to the code machine.
So one thing I did since the last episode is I wrote a test for tracing, and it passed, which is not what I was expecting. I was expecting it to fail and have to fix it. But
so it turns out we were done with tracing at the end of last episode. We just didn't get the time to write the test.
We didn't know. So what the test basically does is it has this number list, which is sort of like a test object, and then that's a host object, and then it allocates a bunch of these heap handles, puts them in the list, and then collects, and everything is still there, and then it drops the list, and it collects, and it's all gone, and it works. Amazing.
There you go. So tonight we talked about how we were going to make a new file that was outside of the heap and start moving some of our client code into that. So we talked about, I don't have the code easily handy, but we talked about how we're going to wire this into the RAN interpreter, which is sort of the next big goal. But to do that, we need to create a value type and the resulting tag pointers.
Yes.
So hopefully we're going to get through some of that tonight.
So do you want to talk a little about what a tag pointer is?
Yes. Well, or you can. But a tag pointer is just a way of more concisely. So naively, we have a pointer to all these things. But if we wanted to store a float in them, or an int, or 0, or null, it's sort of silly to have to separately heap allocate the 0 or the null or the float or the whatever. And so tag pointers are a way to realize that, hey, that pointer that we're using, we could instead just shove an immediate value into it. But if we do that, we have to somehow tag that pointer to say, hey, this is not actually a pointer. You should look inside for its contents instead of chasing the pointer somewhere. And so that's a tag pointer.
Yeah, the whole trick is that because all of our pointers in the heap are aligned, that means we don't actually use all the bits in the pointer. So we can use some of the other bits to say, hey, this actually is a pointer, which means if it's not set, that means it's not a pointer, which means it could be something like a float.
Yep. I remember actually when these were added to JavaScript core. I remember there. And then I remember, I think V8 had them long before I got there. But this is a common trick in these systems because you just don't need to have null be allocated on the heap.
Yeah, it's just like especially bad once you get into these object headers, because if you're trying to store like just a single floating point value, then you like double the size of it because you also have the object header around. Yeah, should we try it? Let's try it.
Yeah, so I think we said we were going to create another file to start to put some of this stuff in, because we have these things in here. That's not the right directory. We have some of these things in here that just like don't belong, like that aren't really related to the like number list, and we have number. We're going to need to add some more of those. What happened to our new function? New file. So sure, client.rs. About the things we're going to do.
So
you're saying? Sorry?
Go ahead. Go for it.
We were talking about sort of our eventual we'll know we're done, quote unquote. It's never quite done, but when we're able to write some primitive functions. So write primitives. That's in life. And by primitive, I mean ones that are like
add. Like you want to add two numbers together, or like append to a list, something like that.
I think that's an I. I don't know. I don't I don't live without spell check. So yeah, so like we want to add numbers, add to a list, and then add strings. And we talked about how this was in the green room. We talked about how these are different types. So this would be like an immediate value. This is like a leaf node host object, so no tracing. This is a root node or something.
Yeah, there are different ways to do lists, but I think the easiest way to do lists is just to have it be a host object that can contain references to other objects. Like if your VM is super fancy, you might re-implement like Rust vec inside of your heap without actually using Rust vec. But I think we can use.
Yeah, so there may actually be another case, and maybe that's another episode and certainly another episode, but like another level of optimization where we do something like that.
Yeah, but I think if we can handle these 3 cases, then we'll have the road pretty well paved for integrating with the Safe Rust VM that we did in earlier episodes.
So I guess we could start with sort of test-driven development of sorts and write out one of these as an example.
Yeah, let's do it.
So if I just copy, I could actually just let's do. I have in a different window. I have one of these many. So like num.
You're literally looking at the safe-ren.
Yeah, so I'm looking at the safe-ren code. So here's safe-ren code, which we don't need to do exactly this, but we could do like num add. We don't need to write a VM pointer, or maybe we do. Do we need like a heap pointer?
I don't know. Let's take it out, and if we need it, we can add it back in. But
you're going to need something to be able to allocate inside one of these, but that's fine. That can be done later. And then you get past args of some form, which doesn't have to be this fancy slicing, but we do need a value type of some form. And then you return some sort of value. And we don't need to validate them in any way. But like if we did num add, we'd want to be able to do something like this, where it's.
What if this was like a local handle, B.
Okay, sure. We can just inline those.
Handle.
Yep.
Just for simplicity, right? And then we want to say like a dot. Do we know that they're numbers at this point? We have to like get the numbers out of them.
We don't like this, so we have to validate. We might know that a is a number.
But in principle, these could return like an error of some sort.
Yeah, exactly.
And then we could say like. So I think we are going to need some kind of VM argument. Just have it be the heap for now, I guess. We somehow need to like tell the heap that we want to
make one of those.
Okay. Local. I'm not sure how all of this is going to work, but like number results is going to return like local handle or a VM error.
Mm-hmm.
Something like that.
Yeah. So are local handles untyped?
I don't know. They can do it different ways.
I don't know either.
It seems like Ren is mostly an untyped kind of language, so maybe untyped is the way to go.
So like value doesn't carry a type with it, but you then have to like get the type out of it. So if local handle is our value in this. But yeah, if we can make this work, that's a big step.
Okay. This is why I always get a little unsure about test-driven development, because you end up doing your sort of API design by what's convenient for your tests. So
we also don't need to. We can just comment this out, but the point was to sort of like see what the end of the road looks like.
Mm-hmm.
We have to make it look exactly like that. Okay. But so in terms of like what the things we need to do, we do need to create some sort of create some sort of value type, like maybe that's local handle.
Right.
Um,
And we want to do a tag pointer, right? So we're going to need some sort of union to represent the tag pointer,
mhm.
and we're going to need some sort of like type ID to represent the what type it is in the union.
Let's create tag pointer. As you said, we need a union, we need a type ID, and do we need like a safe pointer or whatever, like some sort of enum wrapping these things?
Maybe, but I think we should try starting. So I think this is another time to reference this book that we've been looking at.
Mm-hmm. Yeah, that's what I was actually just had up on another screen. This book.
Yes, this book is good. It has a chapter on tag pointers, which we'll be using as sort of a guide to doing this.
One of the things that's nice about this book is that it's very specific to sort of adapting these concepts to Rust. It's like, you want to do these things that we've totally done in other languages for years. This is how you do it in Rust. And specifically the concept of like interpreters, like, which is exactly what we're working in here.
Yeah, so like, for example, here's their type list. So I don't think we need all these things.
Way more types than we need.
We can pare it down. Like,
what's with the repr U16? Is that for like byte alignment or something?
Oh, so this will allow us to store it in the object header because we'll know exactly how many bits it is. So let's just sort of simplify this down. I think we wanted number, we wanted string, we wanted list.
Yep, that's it.
Okay, so we can get rid of the rest of these. Okay.
And then we need. So this is our value type. No, this is our type ID, or what is this?
I think it's like the type ID. We can just call it type ID.
I think they have a separate. I think in this thing they have a separate type ID. They have like constants for the masks. Oh, these are the tags.
So yeah, so this is how they did tag pointers in this book. So here's the tag. Here's the number. I don't think we need the rest of these. We just need.
This is the union, yeah. What's with the symbol and pair? Or the symbol?
I'm not sure.
I don't know if
we need these. I'm not sure what
that's
we do.
sufficient to me.
Yeah.
I've never used non-null.
I don't know what non-null is. What is non-null?
I assume it's a Rustism.
Non-null. I see. It's a non-null pointer. Okay.
Makes sense.
Right. So I think that's okay. So I wonder how big this thing is. Like, is this always a pointer-sized thing?
If you read, it says there's a mut t but non-zero and covariant. This is often the correct thing to use when building data structures using raw pointers, but is ultimately more dangerous to use because of its additional properties. If you're not sure if you want to use non-null t, just use star mut t.
All right.
I have no idea. This is when we bring a Rust expert onto our show and they can explain this all to us.
I'm just copying and pasting more stuff from this book. So here are the constants they use.
Okay.
The tag mask, they're saying the bottom 2 bits they're going to steal for the tag.
Yep.
Number is going to be a 0.
Mm-hmm.
Symbol, and we don't need.
Yep.
So I'm just going to reassign tag object to be 1.
Yep.
And then the pointer mask is all the other bits.
Yep.
So this makes perfect sense to me.
Yep, I agree.
Okay. So should we try to encode a number? But we want a floating point number, right? Like ren is based on.
Correct.
So what should our number be? Is it a F32?
I believe ren uses double, but I'll have to check. It's a good question. I'm checking right now. It's been a while since I've hacked on this code.
64?
I'm checking. Uses F64 for num.
And then I guess
But that's not going to fit inside U16, will it?
U16 is just the ID. Like this is we only need the like 2 bits for the like this value is going to go in the object header.
Mm-hmm.
This value is going to be the tag pointer.
Okay, we're just going to have big pointers because they're holding an F64 inside them.
Yeah, but most computers are 64-bit anyway. So
I do remember things like in JavaScript core, they specifically check the size of the like they don't just store an F64; they store something smaller than that. I think they actually have a custom floating point type they sort of smush in there, and then if it's within certain size constraints, they shove it in. Does that make sense? And otherwise, like if it's above a certain size, they shove it into the object number.
mm-hmm.
Am I making sense?
Yeah. Oh, I see. Yeah, there's like a boxed version, is what you're saying. So yeah. I'm not sure how that's going to work for a floating point number.
Well, I'm just saying that and maybe they have to do some sort of surgery, some sort of masking or whatever to get. This is 15 years ago that I last touched this code, right? To get the floating point number out of the tag pointer. And maybe this is back in the days when these things were all 32-bit size. Well, they probably were.
Yeah, I'm mostly familiar with systems that store integers in tag pointers because I need to say, I don't know, if it's a 62-bit integer, you can fit it or whatever.
Yeah.
So I'm less sure how we're going to do a floating point number. We may need to research the like bit representation of a 64-bit floating point number.
We also could decide that for now we don't do that. We could also look at how Ren does it. Ren C, presumably.
Yeah, let's go look at see how Ren C does it.
I don't know if I have an easy way to open that. I have no idea how I would do that. I have to reshare the new.
That's okay.
The broadcasting setup isn't that fancy.
Yeah, I think if we understand how it's done in the C version, we can probably I feel like we have the parts here in Rust to translate it into Rust.
So I have the Renlang source code. I'm just pulling it up. I bet if I'm figuring this out. I share a different window.
Do you know that they use tag pointers in Ren?
Yes, they do. They actually have like an option to turn them off too. I'm just pulling up the code right now. I don't know if this is really going to be that fast. Maybe we should punt on that for the moment.
Okay. What do you want to do instead?
I'm just saying, like, we don't have to store the like we could make it smaller or something like that. We could do an F32, or we could do just integers. Like, we don't have to solve. I think it's separate from like, can we handle F64 from the do we understand how to do a tag pointer?
Okay, so let's do like just an let's do an I32. That'll be the easiest thing.
Sure.
I think actually iSize is the way to do this. Okay. So now we need to write a thing that will translate between like code 32 give you back a tag pointer. I think the easy way to do this is to say tag pointer number value shifted left by we're using the bottom 2 bits for the tag.
Mm-hmm.
And then we're going to need something that's like code, which takes tagged.
These feel like froms, like into and from,
Oh yeah. You want it that way?
like try into or something like that. I don't know. I don't know what the rusty way to do this is.
Yeah, you're totally right. So how does from work? From
It's like it's something.
32
Yeah, exactly.
for tag pointer.
Mhm.
And then is there like a light bulb that can tell me?
I don't see a light bulb. No. I'm looking to see. Yeah, it looks like there's a whole section on this in the book that we were referencing
Oh, I
from
stopped
these
reading it.
from fat pointers,
Okay.
which is their enum
Mhm.
to so you go from tag pointers to fat pointers to values.
I don't think we need their full structure. We'll just do the basic tag pointer part.
Yeah, that's fine.
So try into is what I want. And for the other direction.
Yeah, try into can fail, whereas into can't. And I think you implement try into. I had to do this, and I'd have to go find the rest of my.
Yeah, I think try into makes sense because we're going to check the tag. And what does it return? Like what is it first for try into?
I have to look. Oh, interesting. This does not use.
You get to pick. Here's like the prototype for it. So we say whatever it is, type error equals error.
Mm-hmm.
I have to import a bunch of stuff to make all this stuff compile. But so then we want to say like tag equals ptr.tag mask off tag pointer mask tag mask. Okay. Match tag. Tag is a number, and we want to return OK of ptr dot number should write by 2 and by 32.
I feel like this 2 is a constant we shouldn't.
Okay, maybe that's it for it. That's a good idea.
Mm-hmm. Yeah.
For we need a new VM error.
Like type error or whatever, yeah. Mm-hmm.
Okay.
Interesting that we're putting this in the client code.
It's probably wrong. We probably should put this in the heap code.
But that's okay. We can start here for now.
Should we put it in the heap code? I think you're right. This goes in the heap code.
I think that the tag pointer and the type ID and stuff, that all goes to the heap.
Okay. We haven't used the type ID yet, so let's move this to heap. That's a good idea.
Okay. Moving to the heap.
Yes. Okay. We need to import a bunch of stuff.
Yep. I need pointer.
This.
Null to unions may not unions not contain fields that need dropping.
Oh. What field needs dropping?
I have no idea. I think that may have been the missing type for cannot find type VM error.
I guess it's called GC error.
I don't remember what we called it. Method try into has a self declaration in the trait, but not in the impl. try and do it as a self-declaration of the trait on the impl.
Okay. We're just being fancy there. We can just write out the actual type.
I don't understand. In the trait, but not the impl?
Yep.
Oh, I see. Method try into as a... I did it again. Mismatch type. Expect I32 found I size.
Yep.
Okay. Method try into as a self-declaration of the trait, but not the impl. Try to do from trait. Okay, that's incompatible type for trait. Expected pointer, function tag pointer. Oh, because it consumes. Access union field is unsafe and requires unsafe function or block.
Right.
Why?
Because I think it doesn't know the discriminant. Like this discriminant action is.
Field is never read. That's fine. We're not dealing with those yet. Okay. Unused import, null.
Okay. Fair enough.
Constant. We've been overused the pointer mask. Okay.
Okay.
Okay. So the idea now is that supposedly in our client code, we can now, in fact, we could just do it this here in our test down here. We want to like create two of these values and add them together or something.
Well, we haven't. Yeah, we could do that.
Yeah, I'm listening.
I was going to say we could integrate this with the heap, so you could store them in the heap. But we can write this test now if you want.
Either way, we need a heap. We have no way to allocate these, do we?
No, we need to somehow integrate like tag pointer. So I think if you go, let's move this code up a little bit. So there's a thing called object pointer.
You're up here. Yep.
So somehow object pointer and tag pointer are related to each other. Like, I feel like the object here is supposed to be object pointer.
Okay. Because tag pointer is the header pointer? Tag pointer is the header?
So I think many places where we say object pointer, we should now say tag pointer. And we should have a to and a from to get to the object pointer. Like the object pointer is the actual like pointer into memory. And tag pointer is some type that we wrapped it up and said, actually, it might secretly be a number instead of a pointer.
Mm-hmm.
So I think we should do the same thing we did for I32, but for object pointer.
Okay. Yeah, you never want to be holding on to object pointers. Like tag pointer is the thing you hold on to. Or some, like if in a fancier system like they were describing in this book.
I think you do this. That's will let us do that. And then for here, this is if tag object. And we want to say, okay, now we need pointer mask. Self dot object and
What's with the tag object? I don't understand.
oh, that's wrong. Sorry. That's supposed to be tag object.
You want the pointer mask that I commented out. Yeah, PTR mask.
I don't know if Russ will allow us to do this, but this is what we want to do. No, this is still tag mask. We're trying to get the tag off.
Oh, I see.
And then if it's an object, then we apply the pointer mask to get the pointer out of it.
Mm-hmm.
This needs to be an object pointer like that. I think Russ is going to be mad. Like
no limitation of object pointer use size.
Right. So maybe this needs to be a usize, and we take this thing as usize.
That sounds dangerous.
And we'll make this thing. I mean, this whole thing is dangerous. Like, it's all.
I'm just going back to the book and reading to see how they did it.
Okay, that's a good idea. How did they do it?
Aha, they have an as word function. So if you read fat pointer to tag pointer, I think it's doing what you want to do.
Okay. What is self? What is raw pointer? Is raw pointer a thing that they made up, or is this like a Rust
No,
thing?
it sounds like a Rusty thing. I mean, I don't know that for a fact, but
I think they made up earlier in there.
let's see. There's their little.
How do they turn it into a?
Their object pointer. It sends it off on a.
Yeah, I think their raw pointer is similar to our object pointer. So we can turn it into the actual numerical value. So is that like SCD transmute?
Sure, that makes sense.
Oops. And then transmute back.
Try to find where it is that they define raw pointer.
All this crazy stuff is on there.
Are you hearing my Windows sing to you?
Yeah, why is it singing? What is it saying?
Because Windows sings. It's singing because Chrome does this. When you search for something and it fails to find it, it beeps at you.
Right.
And the beep, for whatever reason, the default beep is the Windows, multi-chord chime. I'm going to stop following you. Function never used. Tag test. Yeah, fine. We haven't written this yet.
Okay. It accepted the rest of this crazy code? I don't know.
I look away for 10 seconds and
it's pretty powerful, I guess. It's just like, all right.
Okay. So does that mean we can write this now?
Well, I think we need to go audit the rest of our code to see where we're using object pointer that we should be using tag pointer.
So what did you do while I was looking away?
I put a bunch of transmutes. I transmuted it from object pointer to usize, and then I shoved in the tag, and then I transmuted it back after taking out the tag.
Oh, because it's a usize.
Yeah.
Instead of being a non-null pointer.
Yeah, I'm sure there's a way of doing it with non-null pointer too, but whatever. 60. Like at some point, you're just like, I want 64 bits. Give me 64 bits.
Okay. Okay.
Maybe I'm fighting the rustiness, but like
this code needs a serious, bleach bath or whatever. Okay.
Heap cell. I think heap cell now wants to have a tag pointer.
Why does heap cell?
So this is now option header. because it doesn't always have a header. This is going to be like
so the whole idea with tag pointers is that they are copy by value, right? You just copy them around freely. So why would you ever have a handle to one? Isn't that what heap cell is?
because you just have a generic handle to something. You don't know what it is. Like a handle is just a fancy word for pointer.
I see. Well, a handle is a pointer to a pointer, generally, is it not?
Yeah, but this is the second half of it. Like this is the thing you have the pointer to.
Okay. We really need a tidying pass. Okay.
So this thing returns an error if it doesn't match, right? That's not what I want. I want.
You can just do into if you know that it can't error.
What I want to on the error case, I want to return none. Is this like okay, or like?
It's like okay or else, or something like that, or there's a thing for this.
Yeah, I always get confused. Like I want to take a Rust result and make it into an option. Yeah, it's just okay. Yeah, so try into okay map. Okay.
Okay.
Same thing with weak cell. This is tag pointer. Okay, so we have a bunch of stuff. The visitors. These are always.
No, so is it true that the only object pointers should be in tag pointer? That no one else should ever have an object pointer?
That may be the case. Yeah, I think object pointers. I think you only deal with transiently after you recognize what tag you had.
Okay, that makes sense. All object pointer types are now wrong. No, yeah, are all questionable.
Visit header.
Oh, that seems reasonable.
This one seems fine because you have an object header, so you're going to get an object pointer out of it. Okay.
Allocate object. That's also gonna. I mean, depends on how we set up the make tag pointer, like a.
Yeah, allocate object seems like fine because we're going to do like allocate primitive or something, right?
Allocate handle, same thing. We're handing it a.
I think any kind of tag pointer can be made into a handle.
That may be true.
So we should say like configure. Okay.
We're gonna have so many bugs.
Well, the type checking helps a lot here. Otherwise, it gets really tricky.
Okay. Object. Yeah. So that's it.
No other object pointers?
Oh. Oh, 19 of them. I don't know what I'm.
Oh, heap handle. Heap handle needs to be a tag pointer. Okay.
Oh, I see. I was searching backwards. My problem in life. Where'd you go?
Okay. This all looks right.
There.
Okay. What other errors do we have? We have 15 more errors.
Okay, 15 more errors. Tag pointer does not implement debug. Fine.
Right. Go for it.
On it. Debug. It cannot be derived for unions.
All right. Why don't we just why don't we manually implement the debug trait? Just say.
Is this where the the book gets to that, like this tag pointer. So value in the guard, yeah, fine. That's like safe pointer abstraction. Tag pointer. Oh, fat pointer is this thing.
Well, it's like let's not worry about their fat pointers and stuff. Like,
Yeah, I was just trying to understand.
what?
But yes, we could just type in debug.
Here, I'll do that.
Okay.
Look at it, Dean. Okay, we can make it fancier later.
All right, push back, mismatch type tag pointer, found object pointer for our queue.
Just put it dot into.
Just seeing what kind of queue this is.
Oh, actually, the queue should only be object pointers. These are like queues of objects that we have to visit.
Why is this to object pointer return?
Yeah, this is we never have to queue up a tag pointer because if it's a primitive, there's no point.
Yep, no point. Okay, visit header, expected union tag pointer.
Well, I'm on 243. So if I have a heap handle, all right. So this is an option thing. I just need to say if let some header equals envelope pointer at header, and we need to go visit the object. If it doesn't have a header, there's no point in visiting it.
Okay. No method name for object for union tag pointer in current scope.
Okay, we can add that. Where's tag pointer?
I see. Because and it would check the tag type and then return the header if it happened to be an object type.
Yeah, it's just going to try into. It's just if you go up to line 85, you can see type. And option. It's going to be self dot try into.
I think it consumes.
Oh, consumes? Oh, trying to consumes?
I think so. But
Sure.
These are clonable. Yeah, it has copy clone, so it should just it won't care. But that's fine. You can do try into here because it'll just clone the cell to make it work.
We just did something with option object header. Yeah. Oh, the heap cell. Right. So this heap cell implementation is not correct. Heap cell should just be ER. And then this thing that we just did should move into there.
This is option object header.
Yeah. Ampersand what object header. Yeah.
Doesn't like self try into trade bound for from because requirement on. Does this need to be?
Oh, like that.
Maybe. I don't actually know yet. Can't find pointer in the scope. That seemed to work.
I think it's self dot pointer.
Oh, I'm following you again.
Oh, sorry. I'll turn off the.
No, it's fine. I'll turn it off. Okay. Mismatch types. Expected union tag pointer found object pointer.
$250.
Visit header.
Why is it mad? Okay.
Expected union tag pointer.
Oh, the return value. We just need dot into. Another dot into.
Type something. Visit header.
That we need the let sum pattern again.
Because sometimes header might be none.
Correct. We do.
Sure. It feels like something that should just chain.
Yeah, there's like a language proposal for doing it, but
Is it what for doing it?
there's some like a Rust language enhancement proposal that would let you do that. But it's not. There's some obscure reason why it's hard.
Okay. Found tag pointer from object pointer. You're right. There's no way in hell we would do this without types.
No.
Strong types like this. In fact, I suspect that the refactoring that we're doing are things that took months in V8
or you just have to do it the other way. Like you have to always start with tag pointers and never have regular pointers around to mess you up. Okay, so what is going on here? So this is only if it's
we have a cell which may or may not have a pointer to an object pointer. That's our problem, right? This is the let pattern again, right? Right, cell pointer. Because cell, I see, has a tag pointer.
Right, so this is just a header, right? We're trying to get the object header.
Mm-hmm.
We should just say dot header. And this is like an if.
Mm-hmm.
If there's a header, then we need to do a bunch of work.
New header. No field new header pointer in option.
Oh, if let sum.
Yeah. Mm-hmm. Incompatible types.
Dot into.
Because the allocate object returns a tag pointer?
No, it returns an object pointer, and we need to store it. We need to apply the tag, basically. The into to apply the tag is so slick.
Mismatch types. Expected tagged pointer, found object pointer. It's the same thing.
Same thing. Just need a dot into.
This feels like it should be a constructor. That thing. But okay. Mismatch type. Expected union tag pointer, found struct object pointer. Same thing.
Mm-hmm. Yep, go for it.
Because I see, because we
could have done it here, right? We could have said dot into and called this tag pointer. But we don't actually need that, the objectness of it, right?
Sure.
Then we only do it once.
Yeah. It doesn't hurt to do it multiple times, but
yeah, but I don't know. It's conceptually cleaner. We just call this PTR.
No method named adder for union tag pointer.
Okay.
Yeah. Because we don't know. This is not, aha, we've gotten to the...
Right. So this is where global handle, it's going to depend on the type, right? So this
is where you want your value enum you can spit out of this thing.
Right. This get API is incorrect somehow.
Well, the global handle drops its T here somewhere.
Mm-hmm.
Right? Global handle is just a global handle. It's not a global handle T. And it just always has a value.
Right. Do we try that? Why don't we do that as a separate transformation? Let's write that as a to-do. And let's just make this thing panic if it's not a. You're totally right. I just want to like keep the size of the
Yeah, no,
manageable.
I wasn't advocating for that. I was thinking out loud, trying to wrap my head around where we're going.
We get this beautiful unwrap to tell us that something horrible is happening to us.
Oh, I see. So now if we ever try and get on a global handle, we will barf.
It'll panic if it's actually a primitive.
Yeah.
Okay. To do actually handle.
Really, the to do is the get is wrong. The get should return a value or something like that.
This line panics. That's value.
Yeah, that's fine. We're teaching our system about this. All makes sense. Method adder, same idea.
Same idea.
Okay.
No problems. Okay. It must be perfect, right?
Oh, definitely. Oh, it's a test. Okay. Sure. Don't panic. No whammy. No whammy.
That's amazing, by the way. Like,
welcome to Rust.
It's true. You fight with the Rust compiler, but then in the end, it works, and like that is magic. That's a magic moment. I just have to say.
It's just because you wrote C++ for 10 years.
Do you know how hard it is to fight with tagged pointers in C? Like it's just like it's madness because everything is 64 bits, and like, did I mask off the ones or not? Like it's total madness.
Yeah, it's just not possible. Yes, you just added tag pointers into the system in under 40 minutes, and it worked the first time.
It was just like clicking through the air, like, oh, into, out of, try from. I think we should declare victory. I think this is great. This is a big step forward for the system. We could write a test. Why don't we write the test we want to write?
Let's write the test, and then we can really tie a bow on it. We won't have time to talk about pizza, but maybe we will actually. Look at us! Look at us coming in under an hour.
All right. So what is the test we want to write?
But we're gonna have to be careful, dance around the whole.
So we need an allocate number.
Yeah, like a wrap or whatever.
Allocate primitive, yeah.
Which is not the right API, but
no, but it's okay. Allocate number. So, and this is going to give you back a full handle to your beautiful number. And it's going to give you. Oh, it's a beautiful thing. It can't actually fail, which is going to be interesting. And this is going to be a global handle to an I32, I guess. I don't know. Like it's quite like it's like
mysterious. A global handle to a.
Yeah, like it's nonsense, which is fine. But let's just say 32 for now. And
whoa, yeah, because that thinks it has a phantom data to a.
Yeah, like global handle's all messed up, which is fine. Allocate handle I32. Oh, we have to give you the value. Okay, and then we did it, team.
Well, I don't know that you're into. What?
We did it.
Oh man.
Oh man, it's magic. That was the point.
Okay, so we have to do let a equals heap.alloc integer 1.
Oh, 42. Come on. This is America.
We're going to add them.
Oh, I don't know how we're going to get them out, but okay.
We're not going to carefully get them out.
Okay. First of all, now you should assert that the used in the heap is 0. Right. So we may need to build the correct way of getting them out if we actually want to pass this test. This we can pass.
Sure. But all we're doing is testing this. So how would we get them out?
Well, we need the value enum, and we need to have a It would involve destroying the T parameter on global handle.
Or we just add a side method that's like get integer.
Why don't we do get tag pointer? Just add like a I'm on global handle right now.
That's fine. I have a magic follow button that I know how to use now. My broadcasting skills are growing by the day.
It's really just this. Like this is just for testing. I do like config test.
Get pointer? You mean like get tag pointer? But
Yeah.
as I kibitz to the side.
It's like to do remove once we have value.
All right, so now we want a dot get tag pointer. I mean, that's unsafe.
Well, you want to try and do, right? But a value, which is an either to try and do.
Oh, wow.
Oh, yeah.
Oh, yeah. Look at that. I like it. And then we want to assert. Oh, you're adding them. Yeah. We actually don't need to do that. I believe you that we can allocate another one.
Okay, great. Yeah, assert what their values are. Then we'll collect and we'll do it again.
So this is going to be 1 and 2. This is going to be...
this is fine. Yeah, this is good.
We proved that we round trip them. Yeah.
Oh, get tag pointer doesn't have to be mutable, does it?
Cannot borrow A is mutable. Get tag pointer. Why is it never used?
Didn't you call it in your test? Oh, you didn't actually mark this thing as a test. There you go. Now it's
Detail.
actually a test. Boom. This is great. Well, our estimates for tracing were wildly off, but the estimate for tag pointers was pretty good.
It was perfect. Oh, so we have like we're bathed in time tonight. You want to talk about pizza? Did you make pizza this week?
We made pizza last week. We have an innovation in pizza. We took the regular pizza dough and we divided it in half, made 2 mini pizzas, one for each kid. And they love having their own mini pizza. And then they get their nice cheese mini pizzas. And then the adults can have big pizzas with really funny, funky toppings that the kids don't like. It's made peace throughout the land. What about you, Eric? What did you learn this week?
I learned this week. I started playing with Flame last night,
cool.
which is a game thing for Flutter, a game framework. What was I learned this week? Oh, I continue to read this book. I'm trying to use my phone less, and so this is now my breakfast book. So when I have breakfast and lunch, I'm slow. This book is really big, but it's really good, and I'm enjoying it. And
in the 58th minute, should we drop a hint that our guest next week may have something to do with that book?
May have something to do with that book. Anyways, I'm really enjoying the book, and that's what I'm slowly making my way through as I have breakfast every morning. So I'm enjoying it more than the Dragon book, or whichever the compiler one was, which I never made it all the way through.
This book seems more like an artisan's book for like creating, like crafting interpreters, as opposed to the Dragon book is like slay the compiler dragon.
This book has a lot of humor and a lot of there's a lot of voice from the author in there, and I'm just enjoying it. Yeah, been going to bed really early too. I like daylight savings, you know.
Yeah, it's great. I think we should have that all the time. But...
yeah. Anyways, this was great. I'm impressed at how much code was typed, and yeah, now it's like my bedtime. So I will see you next week.
Yeah, see you next week.